There we are. Just so you don't feel left out. Anyway, tonight, what am I going to do tonight? Well, recently I ended up working on a bulldozer that had an electrical problem, but we figured it had lost calibration. It's a fly-by-wire dozer for left levers, forward and reverse, and it has speeds up and down. It's a power shift transmission. And then it has steering. Steering's progressive, so to speak. And the further you go to the right, the more correction it does. If you're going straight ahead and you start moving the lever, essentially what it does is slow the right track down to make a right turn. And then it keeps coming over till the right track stops and then comes around. Usually just before you hit the end there's a little bump and then it stops. Same thing to the left. Well, they lost steering, just gone. And then the blade started doing funny things. This one has 2 cylinders, so it'll pitch. It's just a push blade, and it has some tilt. So the 2 cylinders can move in and out to do the tilt, and then they get it into position you want, then you can extend or retract them. And that part was still working, but it didn't seem to work quite right. And when I first fired it up, the blade started coming up. It's like calibration's out. He says, I know, but I recalibrated it to get there. Well, the calibration kept changing. There's only one way that'll happen, really. There are 2, but there's one main way. The controller isn't holding the setting. Well, before I even got there, I mentioned to him, I said, first thing you do is check your voltage to your battery, check your voltage on your alternator, and check the alternator belts, because I got a feeling they're loose. Loose? Why would it do that? And I said, it screws up the alternator, screws up the feed, and the controller doesn't know what to do, and every once in a while you lose memory because it's doing voltage spikes. Drop all the way down and then spike higher than 24 or 28, that's when it's running. And they found that the belts were loose, and he told me the voltage was okay, running 27, 28 volts. It's okay, that's alright, but it sounds like it caused a problem already. Now, when you're working on systems like this that are not analog, they're actually digital, they call it pulse width modulation. Well, how can you describe it? It's like an alternator or a welder, plug-in-the-wall welder that's DC. You plug it in, AC juice comes in. Transformer drops it down on voltage and raises the amperage and sends it out the other side, still AC. Then it hits a diode bridge that takes both sides of your plus and minus wave for AC and transforms them into out. It's, say, positive and negative. Well, there's diodes out there that block the negative from going out the positive lead, but it creates the difference between the line and the negative on the other side. It's hard to explain, but it's with a diode bridge that makes the differential on the negative side as well as the positive side. So it doesn't just block, it converts. And you end up with wave DC out the other side. Well, pulse width modulation is similar to that, where it takes the bottom part of the wave, it doesn't have it. It just has on, off, on, off. And how long it's on changes how strong the field of electricity is going out. The voltage is the same. It can be 5, it can be 28, it can be 12, depending on your system, 14 I should say. But that's how it operates, is it just, if it's 50-50, well, there's 50% strength out there, and that can be considered halfway. Now, if you take it and send the full signal on all the time, drop the signal at 0 or near 0, just blip, 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 whatever spring or return system you have for it be over here. So what do? They change how long it's on. Over here it's just a blip. Doesn't have enough electrical current overall. If you put an old ammeter on there, you're liable to read full amperage, but it's only on for a brief amount of time. And then the longer you have it on, the stronger the field until you get to full. What's the problem we're having with these is your lever sends voltage reading. Usually 5 volts reference comes in, and as they said in there, 0.5 to 4.5 volts goes back as a reference, as a signal. So there's 5 volts to feed it, a ground on the other side, but in between is a reference signal that takes off of the difference in there on the potentiometer. One goes up, one goes down, so there's 2 signals that go back, tell the controller what's going on. Why 2? So it can differentiate easier between left and right signal, up and down signal. Which one is giving the most juice? So I give it the down signal. And in the middle, they both have roughly the same reading. But, okay, we know it's forward, now we know it's reverse. They have 2 signals, one can back up the other to confirm it, essentially. Well, that's what it does with the voltage. It has 2, and changes them accordingly and sends it to the controller. Controller translates that into input here. On the other side is output wires. Okay? Input, voltage changes from your controls. Output, the controller sends out the milliamps to get the job done. There are 2 different sections in that thing. And what we were reading was a poor reading up here, meaning it was losing and gaining voltage. And we double checked it, and we had our 5 volts in one lever. The other lever, we just figured, let's start with one at a time and see if we can get this working, because we're looking at components that cost anywhere between $1,500 and $8,000. So we wanted to be sure. We checked one to get it there, and he's like, well, we know this one is bad. We disconnected it, measured the resistance. It's bad. Really bad. On 2 legs. Somehow they're crossing themselves over inside the unit, separate from the machine. So we knew we had a problem here. What caused the problem? Well, the way things look, either the controller's having trouble translating, or the controller is the problem. That's kind of what we're looking at now, because there's some ways we couldn't get a voltage feed like we were supposed to. But the milliamp feed, as you move the lever, it would it'd go up and then just sit here and flutter. And then when you got to the end, it'd go bang right to the end where you expected it to. Then it'd fall all the way back and come back up again. It's almost certain to be the controller. How? Well, we're talking about these little signals coming out of here. Little pulse width modulation, the number of times it's on versus the number of times the power is off. Well, when the alternator does its thing and it starts spiking instead of 28 up into the 30s for volts, well, weird stuff happens and you start burning things out. You say, how can that happen? When the belt's loose and you're running at 2200 RPM, 2500 RPM, but I think that one's pretty well set at 2000 to 2200. Big motor, torque engine. SAA 6D 140, I think E2 or E3 Komatsu. I think E3. And I think they jumped over 2. They have E1 and E1 jumped over 2, went to E3. Not sure why. That's just kind of what I remember, but I could be wrong. And that engine is excellent, but when it's running at RPM and the engine speed is changing, the belt loop is changing with the engine speed, and every so often you'll get a snap. That alternator will spin faster and put out more than the regulator can handle. I've seen it. I've also seen it where part of the voltage limiter has failed. And I'm set right there, and I'm measuring 20-some volt, 27.5, 27.7 volts. It's supposed to be 28.1 exactly in this one machine. 28 to 28.1. That's it. I've got less than that, 27.7, 27.5. Any other machine, that's tolerable. On this one, no. And you turned on the accessories, the voltage limiter wasn't working. Shot right up out of sight to 35, 36, 37 volts. Turn it off, turn it off, turn it off. Because I had protections in it, some of the electronics just shut off. We ain't doing that, man. So that's what happened here. We ended up with a controller that got spiked, lost its calibration, and we don't think we can get it back. And there was enough that it damaged at least the one control stick, and probably the other one as well for the blade. Well, the blade has a couple of them that are just plain bang bang. They're on off. You go to float, that's it. You got float. It's bang bang on off. That simple. It's not pulse width modulated. It's on off. But it's the same thing. It goes into the controller, and the controller sends a signal out under the right conditions. So that's what I wanted to do tonight for a quick little reference point as far as what we can do when we're working with fly-by-wire controls. And always remember that some of the things that affect it, can be odd. Now, another one, when you're testing this, depending on who you talk to, you can actually test that pulse width signal on a certain type of meter that has duty cycle, so I'm told. I've never done it because I've usually found the problem long before I ever wanted to do that. So I never bothered with duty cycle. But supposedly duty cycle is how long it's on versus how long it's off. Yeah. Maybe. There's a lot of stuff I haven't tested because I haven't needed to, and the customers don't want you screwing around with just, hey, is this going to work, man? They want to know. Especially when you show up in the job site and you have to tell them when they say, how much is it costing me just for you to show up? $1,000. Huh? And you have to tell them it's $3.50 a mile, plus environmental and miscellaneous charges, and our shop rate at $100 and some an hour, $125 to $150 an hour anymore. Takes you 2 hours to get there. You're at $300 before you even blink. And if it's 2 hours to get there, it can be 80 to 100 miles. $3.50 a mile. So if it's 100 miles and you got $3.50, you just spent $350. Why? It's 100 miles. $3.50 a mile. 2 zeros. Blink, blink. Move the decimal point. Blink, blink. Ooh. Was it? No, not 30. Yeah, $350. It was 33.50. Yeah, 1, 2. So it's $350 gone there. So I told them essentially you're almost $1,000 just for me to show up on the average call. Was every call 2 hours? No, but I tell them local is $500, and anything else, they're gonna nail you. So I showed up. I talked to you. That spends time. I turn around, drive back. It's $500 to $1,000 to show up. Oh crap! Yeah, it's another $500,000 to go back. That wakes their eyes up real fast. The big guys in the gas field, they just didn't care. Please fix my machine and get out of here. And if it was on rental and they didn't do something wrong, that's on us. So we always had something to do that way. And that's one of the reasons I just didn't get into doing some of the testing like that, because it was irrelevant. Didn't need to know. I just mentioned it to you because some of you might be out there in the field and sit there and you're by yourself and turn the meter and see what duty cycle does. It's going to do, not work. Put it on Hertz. See what it does on Hertz. Now, Hertz, and this is a warning, don't buy a cheap meter. I bought some meters that were supposed to be the greatest thing on the planet, and I even got the inductive AC, DC ammeters, loops, the little clip-on, and there's been too many times I've had them not read properly with a good battery. And then I found out if you put the wrong good battery in there, yeah, I had one of them one time that if you put a normal 9 volt, which the only thing you can find is an alkaline, usually was too much and the meter wouldn't work right. You had to have a standard 9 volt battery in there, regular old carbon cell, not an alkaline. Oh. And the battery would last longer than you needed it to. Still, it's all digital, high impedance, etc. But yeah, put the wrong battery in, doesn't work right. Well, of course, every place I work, they're all alkaline, heavy-duty commercial batteries. So I had to buy my own. Anyway, that's just something for you folks to keep in mind as you get to measure things like your hertz out of the wall, your 60 cycles, 50 cycles, whatever they are, to be able to measure it, to confirm them. You need a Mac, Snap-on, or a Fluke meter. What's the other one? Greenlee, some of those, they might be okay, because that's what they're designed for, is AC work. But I think they have duty cycle on some of those as well. So you get a good name brand, you're going to be all right. I've had some cheap meters over the years that work fantastic, but you're talking 1 in 3. I bought a $25 meter, and well, I did too, and I had one that worked beautifully. It was more accurate than the Max and the Snap-ons, we found out later. And some of the guys laughed about it. Where'd you get that? Auto parts store, just bought it off the shelf. It's a great meter. Needed a digital one. I ran analog for years because I didn't need anything. Then I got the digimeter, and I was like, put it on the pressure. It's beautiful. It's this little bitty thing, and you plug in your pressure transducer. Perfect. You just sit there and hold the two in your hand. You're not worried about anything falling because you're holding the whole thing. It was great for a while. So buy the meter, buy the good ones. And the other part too is that if you want to buy a cheap meter and you're on the road or out in the field or ramming around on the farm or whatnot, then what you do is make sure back at the shop you have locked away someplace a good meter, an excellent meter, at least one, if not two. You say, we don't use them that often. No, you don't. But if it doesn't work and that's all you got, and then you use the good meter, 1 or 2 of them, to calibrate or test the calibration of your other cheap $25 back of the pocket, throw it in a pickup truck meter. Yeah, that's right. You use your $300, $400, $500 meter to test the calibration of the other $25, $50 meter you're throwing in your pickup truck. It's worth it. Snap-on had a Blue Point line that was excellent. That's what I used this weekend. Beautiful little meter. It's a little big. It's bigger than the Fluke 101 I have. 101 is so small that this little battery doodad here, that's similar to the size of the Blue Point and double the size of that little teeny Fluke. Problem with the Fluke is it's so small, so light, that if you don't have it restrained someplace, softest Fluke leads that you can find, or Tifcos, will still pull it around. It's a headache. But if you're going someplace and you have to stuff it in your pocket or a small hand toolbox, the thing is great. What's another one? They make something akin to a test light. It has an LED test light in it, but it has a little voltmeter read in there too. I can't remember if I bought it from Matco or Mac. Then that's another one I used. And the funny part was, when I used that against another meter I had, they were like within 1/10 of a volt. It's ridiculously accurate together. These are the kind of things you need to do the testing on these projects. The other one is the backstabbers. They have some that look like modified paper clips, but they're piano wire type, which you can slide in underneath the water seal on the wires to get in touch the contact. I used a direct connect set of those before, but you can get them just the connector and put your clips on it, push them into where you want, put your meter clips on and read. Well, the other one I had was a direct read. Put it right in the end of the lead and poke them in. So I didn't have to even use the gator clips. It was a solid connection. Those are things that are, and good gator clips. You need good point probes. You can get thin point probes to act as a backstabber. They're very long and very thin, and they will stick you like you can't believe. So put them in a place that they're not just fumbling around. Why? Your normal ones stick you, right? These are thin. It doesn't just stick you and stop. It sticks you and can continue. Ouch. No, I haven't gone that far, but darn near. So those are some of the things to take with you. Other ones, if you've taken some of the plugs, electrical plugs, taking some of those. I'm trying to think of the names of them, but anyway, your round plugs, your square plugs, whatever. Take some of the contacts and pigtail wires out of them and build something that you can connect direct, and that's what I use some of those as well. I didn't connect them the way I wanted to, but I was able to take the end of my fluke probes, and they had the male thing inside a sleeve to plug your leads into. I had multiple leads I could put on there. Well, when I took a short wire, a female and male, took the male and poked it in there between the plastic and the contact, they stayed. We were able to make good readings. And it'd be better if it plugged direct and solid, I know, but it was a good connection. And it wasn't cumbersome. It would stay in place. Sometimes when you get a nice gator clips, they're too big, too heavy, and they pull contacts out. So we try to avoid that. So what do we do here? One of the things we did with our testing as well was in the monitor on this one, which you'd have to use a computer. You take your monitor and open it up, and you have the controls. We did the control, I think, first to see what the voltage going in was doing, and then later we did the milliamp test to see what was going out, and the voltage was spiking and doing funny things, and it was almost an identical problem to the milliamps coming out of the controller. Well, this is fed by the controller, and the controller sends the signal out, and that's why we were thinking, all right, we've got two bad controls here and a bad computer controller beside. And he said, yeah, but I don't want to go dropping all that money at once. And I said, well, I hear you. He's going to replace one and then go from there. If it still causes a problem and measures like it did for me, then he knows he has to get the controller and the other stick. But it may cost him $1,500 for the first one if it cooks it again. We'll see what comes up. Anyway, that's what we did for today. Always remember, your controls are inputs. They're going to be measured in volts. They go into your controller. The controller translates your movements and the voltage changes, and then sends that out in a milliamp signal to your actuators, your EPCs, electronic proportioning controls. Fly-by-wire. You folks have a good night. And remember, like I told him, the first place to start is your batteries, your alternators, and your belts for a stable electrical supply. If that's not stable, you can troubleshoot till you're green. It's never going to work right. And that was the thing that we noticed. We were having trouble with the engine on or the engine off. So that's what pointed us to most likely a bad controller. And you hate to say that because that's $5,000 to start. But when you're working on a $500,000 machine, it's a tune-up. You folks have a good night.